Oh, hang on. Alright, what are some things that we did yesterday when we were talking about division? What were some of those words or actions that go with what we are doing? Your laptop is, put it up. Elena? Alright, so we did some work with part, whole. Division can use part, whole to figure that strategy out. Good. Gummy? Yeah, so with division, we are still working with groups. Just like multiplication, we're working with groups of things. Division is the same way. Yeah. Open up the next blank page, get your title down. What else did we do yesterday? Lena? We did put them into groups. We put them into equal groups. Let's add that word. Yep. I am writing. You are definitely writing. We add some equal groups. When I was doing division yesterday, when we were doing division, did we start with like a couple counters?
Yes, when we were growing up.
Did we start all the counters?
No. Well, we started with 12 and we went our way up.
We started with 12 and went up?
Started with 48 and went down.
Yeah, we almost went backwards. We started with our whole pile yesterday of 48 counters. And then from there, started making our groups of 6. Sean? It is very similar to multiplication. We saw that yesterday. There are some big similarities. Very similar to multiplication, especially with that group piece. Victor, if I'm writing, you're writing. Model that we did yesterday. This problem reads, Lincoln has 27 cars that he wants to give to his 3 brothers. Such a good brother. Oh. He wants each brother to receive the same amount of cars. That's fair. How many cars should he give to each brother? Can someone tell me what's happening in this problem in English? I don't want any math. Just tell me what's going down in the Lincoln house. Brayden, what's happening in Lincoln's house? Yeah, he's sharing cars with his brothers, and he wants to make sure that he's sharing fairly, right? We're not playing favorites, are we?
Oh.
No. Every brother's getting the same. Will, you want something to add on?
No.
Okay. First thing we do with a word problem after we read it is to do what? What do I do now? I read the problem, now what? I go. Answer sentence. What am I counting in this problem? What is my unit? What's the thing I'm counting? Logan, what am I counting in this problem? I'm counting what? I am not counting just toys. Lincoln's got a bunch of toys in his house, but that's not what we're talking about here. Look at that problem closely. Yeah, he's specifically giving away toy cars. I don't think Lincoln's giving away his Nerf guns his Xbox games.
Oh.
He is only dealing out his toy cars.
I'll buy one.
What should be my answer sentence? We know that we're counting cars. What should be my answer sentence? Or what could be my answer sentence, Sean?
We can gain one amount of, or, we can gain one.
Blank what? Very good. Lincoln gave blank toy cars to each brother. I know how many he gave to all the brothers. 27. But I want to know how many does each brother get. Lincoln, I'm writing, that means you were writing. Lincoln gave away blank cars. Bella, what's going to go on that blank? A what? A number, yeah. I don't know what that number is yet, but a number. Lincoln gave away blank cars to each brother. That's what this problem is all about. Today we're going to try a new visual model strategy. The same strategy we were looking at yesterday, which is our bar model. So go ahead and draw your bar. With our big arms that say, hey, this big bar, that whole thing is all the same. Yep. I prefer not. Now, we need to fill in some parts of this bar model because we know some things. Look at that problem again. What's something that we know?
He has 27 total.
What's something that we know, Bladen?
He has 27 total.
He has 27 in total. Is he getting any more cars?
No.
No, that's my total amount of cars. So I'm going to put that down here where my W is because W stands for whole. He's not getting any more cars. That's all he got. That's it. What is he doing with them? Look at what are you doing with all those cars? I could subtract them. Are you going to be putting them into groups? Yeah. How many groups? 3. 1 for each brother, yeah? Yeah. Wait. I'm going to draw 3 spaces in my bar. So I got brother number 1 box, brother number 2 box, brother number 3 box. How many of you have ever played Uno or any kind of card game?
I know this. I think so.
Has anyone ever been like the dealer?
Yes.
Have you ever had to deal out cards? Yes.
Sometimes.
Can someone describe to me how you've dealt out cards before? Jackson? Yeah. Exactly. So we can do that same strategy, and I literally call it the dealing out strategy, to figure out this problem. So I'm going to imagine I got 27 cards. They're in my hand. 1 for you, 1 for you, and 1 for you. Is it fair right now?
Yes.
Yeah. Did I use all 27 cards?
No, I didn't
How many cards have I used?
3.
Oh, I know how many cards have I used. I used 3 cards. So I need to go and deal out again. 1 for you, 1 for you, 1 for you. Am I fair? Yeah. How many cards have I used? Ooh, how many cards have I used? Bella? 6. 4, 6. Do I need to keep going? Yeah. 1 for you, 1 for you, 1 for you. 9. I'm going to keep going. 10, 11, 12. Keep going. 13, 14, 15. He's dealed out 15 total cars. Each brother so far has gotten 5. Yes.
I don't know if this is right, but 27 is an odd number, so we all can't get an even number.
Let's find out what happens. I like that attention to detail. Let's find out what happens. I'm at 15, 16, 17, 18, 19, 20, 21. Yes.
Can I expand it a little bit since I can't count?
Yes. 22, 23, 24, 25, 26, 27.
Wait. Is that even?
Yes, you guys are using even incorrectly. Your meaning isn't equal. It is equal. It's not an even number. Does that make sense?
Yeah.
So you guys are changing even and equal, thinking that they meant the same thing, and it doesn't.
Oh, if it was 28, they wouldn't have got 8 cars.
Exactly.
Oh,
Exactly.
so the even number would be,
So, how many cars did each brother get? Did each brother get 27?
9.
How many cars did each brother get, Harper?
14.
Nope, not 14.
No, 9.
9. If you weren't sure, you can count those tally marks for just one brother. Each brother got 9 cars. I kind of skipped the equation piece. Let's talk about the math that matches your picture. Remember, we just started with 27 cars. We started there. We had all those cars. And then Lincoln put them into 3 piles for his brothers. Notice that division symbol. I'm saying put into groups. That's what that is talking about. When I'm dividing, I'm putting into groups. In this problem, I had 3 brothers, so I had to put them into 3 groups.
Oh, so it's going to be 9 because all the...
And then how many was in one group?
9.
9.
That makes sense. Every group has 9. So that's 27.
Now, let's go the other way. Now that I know all the parts and the whole, let's talk about a multiplication equation. How many groups do I have? Brayden, how many groups do I have? 3. Groups of, how many is inside each group? Tinley, how many is inside each group? 9. And what was my total amount of cars that I had? Lincoln? 27. It is very similar to multiplication. You know why, Harper? Because we're putting things in groups. That is what our multiplication and division is all about.
Oh,
Putting things in groups. Sean?
I always just think of division like here. I always just think of it as like just subtracting.
It is very similar to subtracting.
Subtracting and multiplication.
We're going to think about that in just a second. We're going to try another problem. Okay. Alright, let's go to our next problem. You can turn the page if you need to. We probably used the whole page, that's okay. Kenley, Harper, and Ashlyn have 18 apple slices to share. How many slices will each person get? Go ahead and write your answer sentence. Think about what you're counting in this problem. This is the part where you're writing. Answer sentence. What is the thing you are counting? What's your unit? What are you even counting? Elena?
Apple slices.
I am counting apple slices. So I know in my sentence it should say blank apple slices or blank slices, it's fine. What is your answer sentence? Tell me what you wrote. Go for it, Lincoln. Are they giving them away? Pay very close attention to how the question is worded. The question part with the question mark. Will, you want to give it a go? Okay, do you want to try? Jackson? Who? What? Close, not quite. Brayden, you want to try? Yes, Tenley, you don't need the in all piece. Tenley, Harper, and Ashton will get blank apple slices. Each person will get blank apple slices. That'll work. As long as you have something similar to that, that will work. I'm going with each person will get blank apple slices. Our visual model is going to be our bar. I always like to start with the whole. Do I know the total?
Yes.
Do I? Well, you said yeah. Do I know the total? No?
But you said you want to know the total.
Do you know the total? Tell me. What is it? Yeah. We have all the apple slices. Does it say they're going apple picking and getting more apple slices? No. We know how many apple slices they have. They're not getting any more. When you share something, do you get more of it? I don't think so. I don't think so. So my whole is 18 apple slices. The girls aren't getting any more. What else do I know? What else is happening in this problem? They're just going to look at those 18 apple slices and be like, those look tasty. John, what's going to happen?
You have 3 friends that want to share 18 apple slices, so you go twice.
Yeah, I'm going to go ahead and make a Tenley pile, a Harper pile, and an Ashland pile. I'm going to separate them into 3 groups. Let's try that dealing out strategy again. What number am I going to stop at? When I'm dealing out, what number am I going to stop at? Harper? 18, because how many apple slices you got? 18, you're not getting any more. Alright, ready?
Yep.
1 for you, 1 for you, 1 for you. I'm at 3. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16, 17, 18. Notice I stop after each round because I want to make sure everyone has the same amount. We're all about fairness. We're all about those equal groups. What math equation matches what we just did? Think about it. What math equation matches that picture? Go for it, Michael.
3 times 6.
8.
3 times
What did we start with?
6. Division.
What did we start with?
18.
We started with 18. Let's start there. What did we do with those 18? Pick them?
Yeah.
No. What did we do with those 18?
Put them in the equal group.
Put them into equal groups. That tells me it's division. How many groups? 3. Because we're all about fairness. Harper's getting some, Ashley's getting some, Henley's getting some. And how many did each girl end up with? 6. Way to work for that, Michael. That was tough. We started with 18. We put into groups. That tells me it's going to be division. I put it into 3 equal groups, and I ended up with 6 inside each group. Good jam. You want to try the multiplication one? Go for it. Do we have 6 groups? 3 groups of 6 equals 18. Who can come up with another equation? Write it. Yes! Some good old repeated addition. 6 plus 6 plus 6. Here, high five. Awesome. That will totally work. Each person will get 6 apple slices. Turn to the next blank page in your math notebook. No, turn to the next blank page in your math notebook. Right on the back, please. The back. This is your title on the next blank page. It says, describe, in your own words, what is the dealing out strategy? We just did it on 2 problems. Copy that sentence, or sorry, that question at the top of your page. And then I want you to answer it in sentences. And then if you want to draw a picture showing me the dealing out strategy, that'll work too.
Glad you're all work.